Hello everybody, this is Glenn from Keep It Simple, and today we are going to work through a question from Edexcel Paper 1 Mock Set 3. This is question 19. 1 plus root 2 over 3 minus root 2 squared can be written in the form a plus b root 2, find the value of a and find the value of b. Let's start by underlining the key words in the question. A plus b root 2, find the value of a, better underline that, and find the value of b. Now this doesn't necessarily mean that a and b are going to be whole numbers. They can also be fractions, of course. I think what it does mean though is that we have to rationalize the denominator at some point for it to be written in the form a plus b root 2, and in order to do that we have to expand the double brackets. So let's start. Okay, so I have 1 plus root 2 over, I'm going to extend this line because we're going to draw two sets of brackets, 3 minus root 2 in one bracket and 3 minus root 2 in another bracket. We're going to expand these double brackets, so I'll draw my clause. I'm going to do 3 times 3, 3 times minus root 2, minus root 2 times 3, and minus root 2 times minus root 2. So the numerator is going to stay the same, so we have 1 plus root 2 over, okay, so 3 times 3 is 9, 3 times minus root 2 is minus 3 root 2, minus root 2 times 3 is minus 3 root 2. Extend this line. And minus root 2 times minus root 2. So a negative times a negative will give us a positive first. So let's put the positive sign. And root 2 times root 2 is the same as the square root of 4. And we all know that the square root of 4 is indeed 2. I am now going to collect the like terms. So we have 1 plus root 2, the numerator stays the same. 9 plus 2 is 11. Minus 3 lots of root 2, minus 3 lots of root 2, so they're the like terms, will give us minus 6 lots of root 2. We are now going to rationalize the denominator, so I'm going to draw a little multiplication sign. We're going to multiply the numerator, or the denominator and the numerator, by 11 plus 6 root 2. 11 plus 6 root 2. Now the reason we do that is I'm hoping that the minus 6 root 2 and the plus 6 root 2 will cancel out. So I think it might be smart if I rewrite this using double bracket notation. So we have 1 plus root 2 in a bracket here. This is one term, and then we're going to multiply it by 11 plus 6 root 2 over 11 minus 6 root 2, 11 plus 6 root 2. I'm going to draw my clause so you can see exactly what I'm multiplying. 11 with 11, 11 with the 6 root 2, 6 root 2, 6 root 2 with 11, and minus 6 root 2 with the 6 root 2. I'll do the expansion down here. So we have 1 times 11, which will give us 11. 1 times 6 root 2, which is 6 lots of root 2. Root 2 times 11 is 11 lots of root 2. Now this is an interesting one. It's root 2 times 6 root 2, so we can multiply the surds together. So root 2 times root 2 is root 4. The square root of 4 is 2. So we're going to have 6 times 2, which will give us 12. So watch out for that part there. 11 times 11 is 121. 11 times 6 root 2 will give us plus 66 root 2. Minus 6 root 2 times 11 will give us minus 66 root 2. And this is an interesting one. We have minus 6 root 2 times 6 root 2. So let's do with the signs first. A negative times a positive will give us negative. 6 times 6 is going to give us 36. And root 2 times root 2 is going to give us 2. 36 times 2 will give us 72. So we're going to have 72. Now let's collect the like terms. 11 plus 12 is going to give us 23. 6 lots of root 2 plus 11 lots of root 2 is going to give us 17 lots of root 2 over. The plus 66 root 2 and the minus 66 root 2 will cancel out. So we're left with 121 subtract 72. 121 take away 70 is 51. 51 take away 2 will give us 49. Now we're almost there, but we need to write in the form a plus b root 2. So I'm going to write this as 23 over 49. So this is another way of writing this expression. So it's 23 over 49 plus 17 root 2 over 49. And hopefully you'll be able to see where we get our values for a. So a will be 23 over 49. And b will be 17 over 40. Oops, what's happened there? 49. So a and b don't necessarily have to be whole numbers. In this case, they were actually fractions.